Hello, my name is Vasudha Srivastav and I'm recording this video to explain Python threading essentials. So I'll get on to it. Before starting with threading, which is a way of implementing concurrency in Python, I'll get to that later. There's something I want to get out of the way. So there's a lot of confusion usually among students regarding the difference between concurrency and parallelism. We use them interchangeably and we think it is the same thing, but there's a difference between concurrency and parallelism, and I'll explain. So, concurrency means that the CPU will take care of multiple tasks at once. This is the simplest definition. If the CPU is taking care of multiple tasks instead of going like it will it takes one task and it completes it, then it goes on to the other and it completes it, then it goes on to the next. That's not how concurrency works. In concurrency, the CPU is taking care of multiple tasks at once. It is also playing sound. It is also reading what you are typing. It is also displaying. So it is taking care of all these tasks at once. What the concurrency does not means is that the CPU is doing all these tasks at the same time, at the same real time. So let us take the example of a kitchen. So let's say there is a kitchen and five dishes need to be prepared. If the chef uses a non-concurrent approach, he will take a dish, he will start preparing it, and after the dish is done, it will move on to the other dish, and it will start preparing it, and after that is done, it will move on to the next and so on. But in a concurrent system, the chef will take a dish, it will start preparing it, and if let's say it is boiling something, so while that boiling is occurring, there is nothing the chef can do. So it will move on to the next task, the next dish. It will start preparing it. Let's say it has to be kept in the freezer to freeze. So if that is the waiting, it will move on to the next dish, uh, next dish. It will prepare that. It will give its attention to that, and that is how it goes. It is taking care of multiple dishes at once. So that is how CPU handles concurrency too. It takes multiple tasks, but it does not focus on each task one by one. It does one task and then after a fixed time it moves on to the other. It does that where and these context switching. This is called context switching. This happens millions of times in within a second. So that is how concurrency works. What concurrency does not mean, however, is that the CPU is taking care of all these tasks at the same time. So it is switching between these tasks very quickly. It is not performing those in the same time. That would be a parallel environment. If we take our kitchen analogy, in a parallel system, five chefs would be assigned to those five different dishes. So those five different dishes are being prepared at the same time. That is what parallelism means. So if the CPU has four tasks, four processors or four cores of the processor will be handling those four tasks at once. So that is the difference between concurrency and parallelism. Now let's start threading. To understand threading, we need to know what a process is. A process, by definition, is a program under execution. We know what a program is, right? We know that it is a set of instructions the computer has to follow. It could be a Python program you just wrote, it could be WhatsApp, it could be Spotify, it could be the browser. All of these are programs which are written, they have a specific code. And when there's that program is being executed by the CPU, so for example, you open the browser or you open the Spotify app, that program becomes a process because it is being currently executed by the process, by the CPU. A very differentiating property of a process is that each process is allocated resources. So the Chrome process is allocated its own resources in the memory or in the bandwidth, and the Spotify process is allocated its own resources, and the word processor is allocated its own resources. So these are multiple processes in the system. What a thread is that it is the smallest unit of execution in a process. So a thread is a lightweight process, a very simple process. For example, let's say there's a process of a code editor, say VS Code. So the VS Code process has multiple tasks to take care of at once. It needs to do multiple tasks concurrently. And to do that, it uses threading. So threading is a way of doing a process concurrently. What could a concurrent process in VS Code be? There could be a main thread which has to take care of the UI of the VS Code. Then there has to be a thread that is reading what you are typing on the keyboard, and there needs to be a thread which is reading what you have typed, and it is reading the syntax and showing you errors or notations such as which is linting. So there is a process thread for that, and then another thread could be performing autosave tasks at fixed intervals. So that is what threading means. It is a lightweight task inside a process. A thread does not get allocated its own memory. It has to make do or make use of the memory of the process that has been allocated, the process that has started the thread. So there in a system there are multiple processes, and in each process there are multiple threads. So now we know what a thread is. Now, if before moving on to when do we use thread, what is the best time to use a thread, I'll explain what IO bound and CPU bound tasks are. So, a CPU bound task is a task whose execution time is determined solely by the power of the CPU. These tasks are highly algorithmic and mathematical and needs to perform very large calculations. For example, uh, a video editing app. So if you're editing a video, how much time it takes to process that video depends solely on how fast your computer is. If you have faster computer, it will perform those calculations quickly, and you will get the results quicker. So whole CPU is determined to process or determined to take care of that one single task. That is what CPU bound tasks mean. Now let's take the example of loading a web page. So you go to the browser and you load a web page. That is also a process, that is also a task. But the time it takes for that page to load has nothing to do with the speed of your CPU, right? Because your CPU what can your CPU do if the server is taking too much time to send the request, or the network bandwidth it's slow. It does not matter how fast your CPU is. The time it will take to load the process depends solely on the IO. Another example would be reading a file. You cannot read a file faster by having a faster CPU. The speed depends on the speed of the disk or the media, the wire or the network bandwidth. So these type of tasks cannot be performed by strength of CPU. These tasks need time. Okay, so when do we use threading? What is the best time to use threading? Before that, I think I will explain what the multiprocessing and asynchronization are. So I told you what concurrency is, and threading is a way to perform concurrency. There are other ways to perform concurrency, which are multiprocessing and asynchronization. Python has modules for all these three, so that you can decide which model is suitable for your concurrent task, and you can use it accordingly. I'll explain them briefly. So multiprocessing is true parallelism. It performs the tasks parallelly. Where I explained earlier what parallelism is, right? So in threading, the task is not being performed at the same time. No, it is being switched. The context is being switched very quickly. But in multiprocessing, if you give four tasks to the CPU, it will perform those four tasks at the same time using four different cores. So that is what multiprocessing does. What asynchronization is that asynchronization uses a single thread. a single thread takes a task, it performs it, and if a IO operation is being done, so if let's say you are loading a web page, the thread will see that this time will take time. This process will take time. So it will uh, leave that process to the event loop. There is a system called event loop, and then it will move on to the next task. And when that previous task is done, it will send a notification to the main thread, and it will go back and then use the output of the task. So that is how asynchronization works. Now, when do we use threading? I'll tell you what the ideal case for using threading is. Uh, let's say you are you have to create a system which reads user's input. So user is constantly typing some input, but that is the UI. But in addition to taking that input, you also have to take care of displaying that input or sending that input to a server. So if we don't use thread, what will happen is that if the user types something, the CPU will take that input, and then it will, while the CPU is sending that information to the server, the user has to stop writing because the CPU is focused on sending the message to the server, so it cannot detect what the user is typing. So the user has to stop its work, and then after the CPU is done with sending the message, it will come back to the UI, and then if the user types something, it understands it and moves on. But if we use multi-threading, we can create a thread for taking the input from the user, and then another thread will work in the background and send the task to the server. So that is the best case scenario of using thread. You can keep a main thread to work with the UI, and then send the. Now, for the purpose of this video, since the time is limited, I will skip the GIL, and I will move on to the coding part so I can demonstrate the my explanation of code. So there I have also prepared a set of questions for the user to determine if multiprocessing or multi-threading or asynchronization will be suitable for that task. So the students can, solve that. I'll move on and I'll jump into thread creation and starting. So I'll explain the how can you use thread. So we know now what thread are and when to use them. Now I'll get into how we use thread in Python. All the functions related to thread are stored in a module called threading. So first we need to import threading. This module contains all the things that we need to use threading in Python. We will also import a module called time. For I'll tell you why we are using this. Now, to create a, let's say there's a function. Let's say there is a function, and so let's create a function which is a worker. So yeah, okay, I'll take this. So this is a function. Now I'll create a thread, and thread equals threading dot thread. How we So we have created a thread named threading, a thread named thread. Okay, I'll use a simpler name. I'll just call it T1. So T1 is a thread. What this thread does is passed using an argument called target. So we take a parameter called target, and we pass the function that we want the thread to perform. So we are passing it this worker function that I have created. To start a thread, we do t1.start. So this will prompt the thread to start. Now t1.join. what t1.join does is that if we don't use join, let's say we create a thread t1 and we start it and we don't use join, we let the program finish. What will happen is that if the main thread finishes before the T1 is done working, it will just stop and the T1 will stop also. So it will not give time to for T1 to finish what it had started. So that is why we use join. We T1.join means that this is a signal for the main thread to stop its work and wait for T1 to join. So if the main thread encounters this, it will not terminate until T1 is fully executed. And yeah, let's execute it. Let's see what we get. So yeah, it works. Thread is starting, and after 2 seconds, thread is finished. That is how we create it. Now we'll move on to a bit larger explanation. Let's see. Uh, So I'll take this example that I've created. I'll right. So I've actually created a lot, chosen a lot of sample functions, but yeah, I don't think we have enough time to go through them all. This is a Let's go through this function and see what it's doing. So def make request is a function which takes a link. It is just simulating, so we're not taking the actual link. It just takes a link. It makes request to it. Let's assume that it makes request to it. Now these are a list of links, and in this threads list, we will store the threads that we create. For link and link, so for each link in the links, we will create a thread using threading. We'll set the target to make request, the function that we just created, and args. Yeah. So we did not get time to understand what how do we pass arguments, right? So in thread, you can't simply pass arguments to functions like this. You can't do link. This will throw an error. This is not the way. To pass arguments, we set the function name and target and the tuple of the arguments using this keyword args. Now, since there is just a single element, we have used a comma, or else it will not the Python will not interpret it as a tuple. So that is why we used a uh, tailing comma. Now threads.append, the thread is appended to the list of threads, and then we start the thread. For thread in thread, we do thread.join. So we tell the main compiler, interpreter to wait for the thread to finish. And at the end, all the requests will be completed. Yeah, request made. Right. I've There's a sample program that I've created that I want you all to see. Okay. I need you to see the difference between the time it takes to right. So we'll take this program. Just let's comment this one out. We don't need to see it. Use it. Now this. I'm assuming that you've understood what asynchronous and multithreading means. So these are a list of URLs. We are using a function fetch sync, which actually makes request to this URL. I will not explain it because it is not relevant right now. I just need you to see that how much of a difference using multi-threading and asynchronous programming makes. So what this function does is that it fetches the content of these URLs using two methods. First, it does it synchronously, so it takes one and then moves on to the other. The other function does it using multi-threading, so it creates a thread for each. And the last one does asynchronization. So let's execute and see how it goes. See, the asynchronous version took 3.35 seconds. But if we do the same task with multi-threading, we can do it in only 1.1 seconds. That's like one third of the task. And asynchronous is taking slightly more than threading, which is not actually the case. I have told you how async is very useful when you have a large number of IO requests. That is where async shines. But async has a overhead which makes it slightly less desirable for small tasks. So if the list were of say thousands of tens of thousands of requests, async would do better than multi-threading. But since here we are using a smaller list, threading is performing. So, yeah, I will be terminating the video now. Thanks.